Hello, so today we're looking at upper and lower rectangles. So what are those, you tell me? A lower and upper rectangle is one of the informal ways we introduce you to finding the area underneath a curve. So we've been looking at integration for the last couple of videos. We've looked at anti-differentiation, we've looked at indefinite integrals, and we started looking at definite integrals. And that led us to upper and lower rectangles, sometimes known as Riemann sums. So what are these things I'm talking about? The upper and lower rectangles are the way that we can estimate the area underneath a curve, which essentially is what integration is doing for us. So when it comes to upper and lower rectangles, I'm going to talk through a few key points to help you remember how we sketch these and how we calculate each of them. So let's get to it. Let's look at this first example up here. We've got a graph where we've got 1/2 of y equals x squared. And we want to find the lower rectangles. So if we're trying to find the lower rectangles, what we're trying to do here is we're trying to find an area underneath here that's going to be kind of an underestimate. We're going to have spaces between the curve and the rectangles. Another way that we can think of this is we can call this here left end point. So left end point, what does that mean? That means when I start sketching the graph or the rectangles, my rectangle on the left hand side is going to be touching that graph. And when it's touching that graph, that's where the left end point meets. So what this here is telling me is that when I start sketching my graph, if it's a left end point, I start from the left hand side. So let's do an example here with this equation or this graph, and then we'll look at a second graph. So we know we've got the equation of y equals x cubed. Let's put some information in here. We want to find the area between x is equal to 1 and x is equal to 3. And we want to use 4 rectangles. So we're going to draw 4 rectangles under here to help us work out or estimate what the area of this is going to be. So let's get to some maths. In order to do this, we need to work out, well, what width are each of these rectangles going to be? Well, I know from here to here, I need to have 4 rectangles. So I need to work out, well, how wide should each of them be? So we need to calculate the width. So the first step we do in calculating this lower or upper rectangles, we find the width. And the width is found by the difference between your two x variables here. So 3 minus 1, and we divide it by how many rectangles we want. Okay. This gives us 2 over 4, so therefore the width is actually 1/2. So each rectangle should be 1/2 in width. So we can now fix this up here, starting from 1, let's put in 1.5, 2, 2.5, 3. So there's going to be my 4 rectangles. Our next thing we're going to do here is we're going to start sketching these rectangles. Because we're going for the lower rectangles, we're going to go from the left hand side. So let's have a look at doing that first. Starting from the left, our first one is 1. So we start from 1, we sketch up until it touches the curve. We then go to the next part. The next rectangle starts at 1.5, goes up, touches the curve. The next one, go another 1/2 up, 2, and then 2.5. Once we've got our lower rectangle set, we now start going from the left hand side to the right. So this is why it's called left end point. So left end, left hand, left hand. Now I know what you're saying, there's only 3 rectangles there. Well, the 4th rectangle is here. What we don't do is we don't sketch that all the way up because we don't want to include that 3rd as the right hand. Here we come across and we sketch our 4th rectangle here. And that gives us that 4th rectangle. Left end point means we touch the left hand side of those rectangles. Now we've done that, what we want to do is, well, we want to work out what is that area going to be. Generally, area of a rectangle is the width times by how high it is. I don't know how high this is here, but I do know that y is equal to x any value in here. So if I plug 1 into this equation, I should get what the y coordinate that's going to be. So therefore, 1 times 1 is 1. 1.5 times, or 1.5 squared gives me 2.25. 2 squared is 4, and 2.5 squared is 6.25. So we've got all those. So quickly again, how I got this is I just said, well, if I wanted to get this value here, y is equal to 1 squared. I want to get this one, y is equal to 1.5 squared, and so on, and I got those values. I now have this information to help me work out an estimate underneath this curve. So the way that we set this out here is we say, well, we know that the width of the curve is half. So area is equal to half times the sum of all these numbers. So 1 plus 2.5 plus 4 plus 6.25. And the reason I'm doing that is because I'm working out the individual heights of each of these rectangles. So 1 times 1, half times 1, another half times 1.5. So we're working it out. If we plug that into your calculator, and let's see, I'll get my calculator out and do it for us right now. So what have we got? We've got 0.5 brackets, 1 plus 2.25 plus 4 plus 6.25. We get an area of 6.25 units squared. Remember, this here is an estimate. Lower rectangles are telling me that this is not going to be as accurate as possible because you can see I have gaps between each of these rectangles that are touching the curve. So if I was going to decrease or increase the number of rectangles, then that means the width is going to decrease, and therefore this little gap between the curve and the rectangle will decrease, so therefore my accuracy for the curve or the area will increase. Alright, let's sketch up a second graph and do the same thing, but this time we're going to look at what we call upper rectangles.